My name is Ho-Jung Kim. I'm running a database of Knox Portal, a Groupware system, and Samsung SDS. This session is about MariaDB being used for the Knox Portal. By any chance, has anyone heard of Knox Portal or Samsung Groupware system? Please raise your hands. Okay. So that's why I'm here to tell you about this. First, I will briefly introduce Knox Portal RDB to you. Next, I would like to introduce our work case for the zero-downtime upgrading. Then, I will talk about the improvements and difficulties of current architecture. Finally, I will conclude my presentation. Knox Portal is a business portal system that Samsung employees use at work, such as for email, mobile work, scheduling, meeting, community, etc. In other words, it is a comprehensive solution offering all work environments for Samsung employees. You can see the detailed service status provided to Samsung employees. 3 services, 6 areas, and more than about 30 detailed services are provided to employees. At work, we check email and reply. We can schedule work through Teams, have video conference using the meeting solution, and communicate through Messenger. If we have time, we can use blogs and community services. In this chapter, Knox Portal usage is expressed in numbers. About 80 companies and 500,000 employees are using various services, such as email, approval, messenger, and mobile. It's also connected to about 2,000 other systems within the organization. And the remaining number is the usage of representative services for the months. Knox Portal was first made in 1991. Until 2016, all RDBs used by Knox Portal were serviced through Oracle DB. About 25 years later, in 2016, there were many changes. At that time, there were 2 main topics. These were MSA and open source. Of course, it is still an important part of the IT trend. RDBMS as well as WebOS were no exceptions. After much review, we prepared for the change to open source MariaDB. In this chapter, I will introduce the current status of RDB in operation. As you can see, Oracle DB was the main RDB in 2015. After many changes, MariaDB currently operates about 50 services in 3 regions. For major data, real-time data synchronization is being conducted across 3 regions. At the same time as switching to MariaDB, customer requirements had to be combined. First of all, it was a demand for the use of open source. It's the most important factor for IT trend. Also, it was costly to use Oracle DB. Then, it was the customer's request for zero-downtime of service. Even if there was an issue, we needed a quick restoration. In order to switch RDB without downtime, development of a CDC solution was essential. From this chapter, I would like to introduce two cases of RDB switching without downtime. It is divided into two sections. For 18 to 22, for about 5 years, we have switched main services from Oracle to MariaDB without any downtime. Also in the 20th year, we proceeded to upgrade MariaDB version without downtime. I will share the details based on the above two cases. In the process of designing the work, it was necessary to review into two sections. First, the data had to be processed according to the RDB data format to be changed. Next, architecture design was important because it needed to be converted from an online environment. I will explain more about the details in the next chapter. At first, I checked the tool to transfer the data. So I looked into tools such as ESF database migration toolkit, SQL lines data, SQL log, etc. We checked many problems by using each of these tools. First, it was impossible to process in parallel. In addition, lab data was the biggest problem. To make matters worse, some data had not been transferred. Moreover, I couldn't confirm the cause because there was no log provided by the tool. Due to these reasons, I couldn't use the migration tool. Requirements have been arranged to solve the problem. What I'm going to talk about from now on are the key tasks that I applied when migrating. Oracle and MariaDB have different ways of storing blank and null data. Also, the format for the timestamp value needed to be changed. Then, auto increment initial setup was required. In addition, it was necessary to reduce the transfer time. As you know, lab is a risk factor for generating DB performance issues. In order to operate RDB lightly, I suggested to transfer lab data to object storage for service. In addition, creating an index after migration could reduce the transfer time. Based on what I said, we have built an architecture to meet all the requirements through our own function and CDC solution. These are the contents applied while developing the function. I changed the timestamp format as shown on the screen. Also, the data of each table was exported to CSV file. At the time of importing the data, the character set was specified and blank data was converted. This is the architecture of the CDC solution. Using Oracle's archive logs, the extractor process extracts data in real time. This extracted data is released to the target database in parallel through the replicator process. Each extractor and replicator process is installed and operated in OS where source and target database are installed. It is also possible to function remotely from a separate server. The developed CDC solution is named async. The number 8 containing the meaning of uninterrupted and continuous, and sync an abbreviation for synchronization. This page is about zero-downtime architecture. First, we deployed the async process between both DBs. Next, proceed with the data migration and rerun the CDC solution, we must set the SCM value before starting the process. This is because we needed to process the change from the SCM value at the time of export for data migration. Then we confirm that data synchronization is proceeding stably between RDBs in real time. After monitoring for several days and confirming that everything is normal, we will change the DB access IP of the RUS and proceed with the process. Changing the DB access IP of the RUS will result in real-time synchronization of incremental data from MariaDB to Oracle using async. If there is a problem with the function and performance, it is possible to quickly address it by switching back to Oracle. This is the overall zero-downtime architecture I designed. In this chapter, we will discuss one of the key technologies used in bidirectional synchronization. The key point in bidirectional synchronization is preventing data from looping. First, we extract the event of changed data from the source database. Then, we specify the text name at the transaction level. And finally, in the target database, we skip the specified text name transaction and extract the data. By following these steps, we are able to prevent the looping of data. The second case I'm going to talk about from now on is similar to case number one. The number of services operated through MariaDB has increased. And 1 to 2 years, the major version of US was approaching. Many servers under management could not be upgraded in a short time. Also, we needed an environment where we could restore it as soon as the issue occurred. It's a zero-downtime architecture for the second case. Messenger MariaDB, a service for employee communication, was operating in Worm Master 6 replica configuration. When the server needs to be replaced, we configured the new set in the same way. And we reviewed the application of data synchronization through MariaDB replication between the two sets. However, there was an issue. DB version compatibility has been confirmed. This page is posted on MariaDB official website. As you know, master replica configuration does not matter for replication to an alpha version. However, it was said that there is a problem with the compatibility of replication to the lower version. In other words, it was impossible to configure synchronization between the two databases through MariaDB replication. Some contents were introduced in the previous chapter, so I will focus on the other points. The difference is that async was developed to extract binlog data using an open source library called Maxwell. The location where the process is installed and the operation function are the same as explained earlier. Finally, it was configured as shown in the zero-downtime architecture. Data is synchronized in real time through the async between both ZDB. However, considering the importance of the service, we proceeded with the DB access IP of WAS sequentially. Service number 1 is less important to us. Service number 2 was a WAS service with select transaction through query offloading. Service 3 was a WAS service available for both read and write. We changed the access IP sequentially like this. So I was able to upgrade DB stably. Now to conclude what I have to say today. We have multiple service environments beyond the 2 cases we introduced. In addition to MariaDB, MySQL, and Oracle, we have also set up and maintained synchronization environment with storage solutions such as file server and Active Directory. Furthermore, we have developed support for various sync configuration. Lastly, it is a problem caused by a lot of DBs that needed to be managed. Although the EOL period was not imminent, it felt like it was coming up every 2 years. Also, I had to check the bug fix from time to time. I'm not used to presenting in English, so some parts may have been difficult for you to understand. So let's have Q&A time.
Does anyone have any questions around the audience? Otherwise, in between, I'm going to integrate any questions from the virtual world.
Yeah. Can you explain the extractor process that you used to extract the binary logs, the archive logs from Oracle?
Oracle can extract read logs in real time at a rate of 20 gigabytes per hour in real time. And in the case of MariaDB, we were able to extract up to 1,500 QPS in real time based on our 1 kilobyte row size in our test environment.
Basically, so async, that is an in-house developed solution they have. So they're using it for the CDC solution tool, and then for the bidirectional replication tool too. So maybe that is not answering your question in detail, but kind of in-house solutions they have.
Oh, 1 second.
Yeah, hi. Do you know what is the scale of MariaDB deployment in your environment? Is it large scale deployment or?
What's that mean? So scale?
The number of databases, I mean, legacy versus MariaDB. Is it?
서버가 예전에 오라클 한 몇 개 정도 쓰다가 이제
오라클 한 25개 정도에서 지금 한 100여 개 정도 쓰고 있어요. MariaDB.
So usually they used to use about 25 of Oracle legacy, and then now they're using MariaDB over 100 of servers.
Okay. Okay.
Yeah.
Thank you. I have another question.
Yep.
Regarding the zero downtime upgrade. By any chance, do you need to roll back? Because you have just shown that from 10.0 to 10.3, because all the backout plans all very well planned in advance, right? So by any chance you need to roll back after the upgrade because of any issues, you have to go back to 10.0?
혹시 실제로 마이그레이션 업그레이드하다가 원복한 사례가 있나요?
Yes, we upgraded some services to version 10.6 last month. The data extraction result according to the change in the execution plan was departed from the previous version, so it was restored it. It was an alignment issue using row num.
Okay.
Yeah,
So it worked perfectly. Yes. Okay. Thank you.
This refers to the recovery procedure. What happens if there's interruptive power on and off? Will your system be able to recover fully?
파워가 만약에 나갔을 때 어떻게 장애를 극복하는지 물어보시는 그런 HA 플랜 같은 거 파워
그럼 센터 원전 전역장인데 저희는 DR 서비스 서버가 있고요. 존이 완전히 다르고 메인 서비스가 나가면은 DR 서비스를 가동을 해서 모든 서비스의 지속성을 유지한다 이렇게 설명드립니다.
So they have a HA plan, and then they already set up the DR on the other data center. So even if there's any power failure in one center, they can switch it to the DR center. Yeah. Yeah.
We have time for at least one or two more questions. I'm going to go to a couple we had here. Are you able to maintain real-time synchronization, or have you already?
Yes, maintain 동기화 성능 말하는 거예요.
Yeah. So synchronization for what?
For the backups.
For backups. 백업 하는 거에 혹시 백업 플랜이 현재 어떻게 되나요?
저희는
You do snapshots of
스냅샷을 원데이에 한 번만 하고 있습니다.
So they're taking full backup daily.
daily.
Yeah.
Okay. So it's bad. Okay. Any other questions? Okay, I've just one more. So in 2016 to 2023, this is my question. You had you've gone from 20 apps that were running with Oracle to 50.
Yep.
In the next 5 years, what's your projection for the number of apps that moves to?
So 이후 현재 이제 한 20개 오라클에서 지금 뭐 장표상으로 50개 정도로 이제
네.
마리아DB를 넘어왔는데
네.
그 이후에 혹시 이제 또 플랜은 어떻게 보고 있는지.
RDB 변경 작업에 대한 계획은 없고 저희 이제 가상화를 전환하거나 아니면 클라우드 환경으로 전환하는 거에 대한 그 플랜은 갖고 있어요.
So I think they almost done with migrating from the Oracle to MariaDB already, but in the perspective of infrastructure, they are planning to moving it to the private cloud and then some of the other infrastructure form. Yeah.
Okay.
Yeah.
Okay, well, thank you all for attending this session.